mode.
Good afternoon, everyone. This is Mark Albert, Editor-in-Chief of Modern Machine Shop Magazine. Welcome to our webinar sponsored by FANUC America. Thank you for joining us. Our topic this afternoon is FANUC 5-axis machining 101. If you are just getting started with 5-axis machining, or even just exploring the idea of it for the future, it can be a daunting task at first to tackle this technology on your own. Having an expert guide you in the right direction and warn you about common errors will make the process easier and more efficient. This webinar will help you get started by telling you what you need in option content, parameter content, and programming instructions to enable FANUC's high-speed smooth TCP, Workpiece Setting Error Compensation, tilted working plane, and other advanced functions to perform effectively. Our presenter this afternoon is Jody Michaels. As Aftermarket Support Manager for FANUC America, Jody Michaels' focus is on servicing and supporting end users to maximize their productivity with the use of FANUC CNCs. Jody has 35 years experience in the machine tool industry with various positions in sales, support, automotive applications, and training at machine tool builders, end users, and CNC suppliers. As we listen to Jody during the presentation, please feel free to share your questions with us by typing them in the questions pane on your control panel. He will answer those questions at the end of the presentation as time allows. This webinar is being recorded, so you will be able to view the entire program online later. So thanks again for taking time to be with us for the live program. Here's Jody.
Thanks, Mark, for that introduction. And again, I want to introduce myself, just reiterate what Mark said. My name is Jody Michaels. I am the manager of the Aftermarket Support Group. And just to, before I go on to the meat of the presentation, I just want to go over the structure of FANUC itself to sort of explain, what my group does, and then also some of the people that we work with very closely, especially on the 5-axis machining side. Because, in this slide, you can see that I've got Rick Schultz's name, and he's the Aero Structures Program Manager, and Mark Lohmeyer, who's the Aero Engine Program Manager, and they work for the Vertical Marketing Group. And what they do, they try to get with builders and large end users to make sure that they have 5-axis machines spec'd out correctly before they purchase the machines, to help them up front to do that. And also after the fact, Rick and Mark work with builders, large end users, to help support them on the 5-axis side. And actually, both of them know much more about 5-axis than I do, but my group, what we do is once the Aftermarket Support Group, once the machine is sold and it gets on the end user's floor, my group can help you with training, parts, options, service contracts, or even helping with trying to get 5-axis machining turned on and making it efficient. So that's what the Aftermarket Support Group does. So then from there, what we're going to go into is, say, as Mark said, if you're trying to get into 5-axis machining, you want to go into what options you actually need. And obviously, Rick and Mark both can help you with all those specifications, because there's a lot of them. But these 6 here that I've got on this screen are some of the highlights of what you're going to need. The first 3 have to do with high-speed machining. You got HRV Control 2, high-speed processing, look-head blocks expansion, and then for the 5-axis stuff, high-speed smooth TCP, Workpiece Setting Error Compensation, 3-dimensional manual feed, and these are just some of the ones that you want to make sure that you have. Obviously, like I said, Rick and Mark can help you with a more complete list, because it would take up several several different screens to show them all. And then what we want to go from there, we want to go, I want to show you a sample program, because as I've traveled around and talked to different end users, people are always asking me what the format is of a program in 5-axis. And, working with that, this is a sample program. And, the sequence of events that you need to put in a program, typically at the beginning you're going to have your standard startup modes where you want to cancel any modes that you might have turned on during the program. So with this, you got a program number, and at the beginning what you want to do is like a G54.4, that cancels Workpiece Setting Error Compensation. G80 will cancel any drill or tapping cycles. G40 will turn on any tool radius compensation, whether it be 3-dimensional or standard tool nose radius compensation. G49 will turn off tool center point. G59 will turn off any tilted working plane or coordinate rotation. And then G54 will get you back to your standard work offset. So it's important that you have this at the beginning of the program, along with G90 for absolute, G20 or G21 whether you're doing inch or metric programming. G94 will get you back into feet per minute. G17 XY plane, and then G64 cutting mode. So that's all just basic startup information. But then after you do that, that's your basic startup. The first thing you need to do when you do a 5-axis program up front, you want to get to where you want to tell the control where the part is. And that's what's key about Workpiece Setting Error Compensation. That sort of sets up where that part is located. And that's what the G54.4 P1 does. The G54.4 is the actual WSEC, and then the P is the actual offset. Okay, and we'll go into that deeper as we go through my presentation. Then the next thing you do, you activate AiCC. And the R word is the level of precision. So you have G5.1, Q1, R1. And again, we'll go deeper into that. But this is just a sample program. Then you want to activate your tool center point. And you do that with G43.4 with an H word, that's your offset number. And then P1 will activate tool posture control. And you want to do at least that level when you turn on tool center point control. Also at this point, you can activate 3-dimensional cutter compensation if necessary. You don't have to do this, but here's where you would do it. Then at this point, you would do whatever your part program was actually going to do, whatever moves you want to make. And then at the end of the program, you always want to go back and make sure you turn all this stuff back off. Because with tool center point, you always want to make sure that it's deactivated. Because strange things can happen if you don't remember to turn that off. Okay? So you use a G40 to turn off the tool nose radius comp. G49 will cancel the tool center point control. The G5.1 Q0 will turn off the look ahead. Then the G91, G28, that's just returning to a reference point. You could either use that or a G53. Either one of those would work. Then go back into absolute. Then the end of the program. So that's just a sample program. I just want to go through that in the beginning so you understand what a program looks like, the beginning and the end, what you need to turn on and off. So the first thing we want to talk about, and again, this is just sort of a sequence of events in a program. The first thing you want to talk about is Workpiece Setting Error Compensation, because with that, what we're doing, we're telling it where the part is. We're letting the control where it's located. Because when you do 5-axis machining, I'm an old machine operator, because, at some point with 5-axis, you got to get a hold of the part. You have to have some sort of work holding where you can clamp onto the part. This isn't like a 3-axis machine where you're going to throw this part up in a vise, because you're going to run into interference zones. So with the Workpiece Setting Error Compensation, that gives you the capability of, if you take the part on and off whatever fixture you're using, you can tell the machine where it's located after you actually maybe machine it or move it. And with this, again, this is just saying that when it's placed on the table, the workpiece is not always at an ideal function, at an ideal position. With this, you can rotate it around using Workpiece Setting Error Compensation. It's like a work offset. And with that, with your Workpiece Setting Error Compensation, you have 7 different offsets, plus you have a common that's more like a work shift. And the work shift works in conjunction with the P1 through P7. Okay, so it'll work together with those. Okay, now this is a sample screen of what it actually looks like. And when you actually turn it on, it will come up where it shows active workpiece. It will actually show that. And then, again, we're identifying the part location. So you only have to program in part coordinates. And, there's 2 ways you can use. You can use Workpiece Setting Error Compensation with a G54.4 or tilted work plane with a G68.2 that identifies where the part is. Again, it's critical letting the control know where the part is. And then at this point, we're going to go into, I'm going to show videos throughout our presentation. And at this point, I want to sort of show you a short video of and what it does here. Hold on just a second. It's machining the part, and then for whatever reason, this is just an example, a graphic representation. You're going to take the part off and inspect it or whatever you might do. And then, this is going to be a gross exaggeration, but when you put it back on the table, you can't get it back in the same exact spot. Okay? So at this point, then you can use Workpiece Setting Error Compensation to get it back to where it was. All right, so that's the beauty of that. And now if we go back to our PowerPoint presentation, again, it's important that you identify the part location. And then with Workpiece Setting Error Compensation, you can use it to offset an error on your workpiece, your work holding. And with it, you can turn on Tool Center Point Control, 3-dimensional tool nose radius compensation, and tilted working plane all at the same time. So you can have all those in effect while you're doing this. Okay? And then, again, just to beat you over the head about how the format for programming this, it's a G54.4 with a P word. Again, the P word is the offset number. You have P1 through 7. And again, like I reiterated before, you can use the common can be used in conjunction with those. Okay, again, that shows the Workpiece Setting Error Compensation. And then from there, we're going to get into tilted working plane. And this works in conjunction with our Workpiece Setting Error Compensation. And with this, again, it gives you the capability of where you only have to program based on an XYZ program. You don't have to allow for a plane, because with tilted working plane, with a G68.2 or a G53.1, we can tell it where the part is setting and still use the same program. And this is just another screen showing how you program it with a G68.2. And again, the various commands, you have roll, pitch, and yaw, the 3-point commands, the 2 vectors command, and the projection angle corner. And with this, on the 30 series control, there is a guidance screen that's added. And within that, it makes it very easy to edit and change these different features. And as you can see, it's got G68.2, G68.4 with different P words. So it makes it very easy actually editing this feature. And then also, it will have Also on the 30 series control, you can have manual guide eye. Within manual guide eye, it also supports this feature for up to 4 axis, not 5 axis, but 4 axis. But I wanted to show it anyway because this is a graphic representation where you can just fill in the blanks and put this into the program. Again, roll, pitch, and yaw, and it's just a matter of filling in the blanks. Okay? Then the 3 points. 3 points, the second tab, the 2 vectors, the projection angle, and the tool direction. And now that we're here, what I want to do is go back and show a video of this feature also, tilted working plane. And again, what this is going to show is in machining several different areas on this part using the same program. So it's machining this V, in your standard XYZ. Then it does it on a tilted surface, and you can see how it shows the different work coordinates, with the 3-finger rule there, like Eric always used to say. And then you can tilt it another direction, still use basically the same program. It's cutting the same shape, but on a different angle. And then you just tilt it around and go do on the other side. Okay, so that's tilted working plane. So we'll go back into our PowerPoint presentation. Okay, so now what we're going to get into is tool center point control. That's the third leg of what we're talking about. Okay, this is going to be a 4-legged animal that we're working with. So with tool center point, we got 2 types. We got type 1 and type 2. With type 1, you use a G43.4 with an H word for your tool length and your pivot distance or whatever it might be, along with an X, Y, Z, A and B, B and C, or whatever your rotary axes are. And then type 2, you use a G43.5 with an H word. The Q is the angle of the tool, and you use an I, J, and K. All right? And with that, you show the different rotation axis angles with type 1. So it'd be like A minus 30, C minus 110. Type 2 are the vectors type. And at this point, then, again, I'm going to go into some videos that we have. We're going to show 3 of them this time. So just bear with me, but it's just going to show the different types. Hold on just a second. It stays with that center point when you move the different angles. And then the next one we're going to show with vectors. With this one, you're using I, J, and K. And you can see it moves. Let me play that again so you understand what it's doing. Again, we're using vectors to control. And then the next one is actually a real video of a machine that's an a C over B table. And with this video, it moves, and see, you can show it going around with the C axis. Then it rotates the B, and it moves around with the C axis. So let's play that. Let's play that again so you can see that. So it's you can see the TCP, it's moving around with the C axis. As we play it again, we move the B, and we move it around again. And I apologize where we got the part covered up there, but obviously that was a part that I couldn't show you in this video. But again, that's the different types of rotation, how it works, whether it would be with the angles or the vectors. And again, what you get improved finish, surface finish to the tooltip programming. And again, now I'm going to show another video. Now with this, the first one is going to show tool center point turned off. And again, with this, you can tell when it gets down into where it's doing full 5-axis contouring. See how it sort of is, there's a slight amount of hesitation there, okay, as it's going through that. Right there as it's doing that area, that cut, where it does slow down a little bit. And again, this was TCP turned off. This is a TCP turned off. But then if we go back and play the next one where it's turned on with this one, now watch how it's so much smoother. It's totally smoother, and that's with tool center point turned on. So that sort of shows you the differences between when it's turned on and when it's turned off. So you can totally tell the difference. All right. Now we're going to go back into our PowerPoint presentation. Let me expand it so you get better finish. And then also, at this point, now we want to start talking about some of the parameters that are associated with tool center point control. Now, one of the most important ones that you got to do up front is, and there's a large variety of these, but 1968 is one of the critical ones because this is where you define the type of machine that you've got. And you got 4 choices here. And, you know, this is in our parameter book, but it's something you want to make sure that you have set correctly. Because you have the 4 choices are 0, where you have no rotation axes, and 2, and that's where the tool is tilting. The head tilts 2 different ways. 12 would be a table rotation type, and with that you'd have like a B axis with something on top of it. And then 21, that would be a mixed type. With a mixed type you would have where the tool is moving one way and the table is moving one way. So that's a mixed type. And like I said, it's critical that you get this parameter set correctly because funny things can happen if you have this mismatch with your actual machine. Okay. Then also we do have a variety of, there's about 20 parameters here in the next 2 pages that you have to check. And this is another thing that, you know, when you're doing this type of machining, obviously when you first install the machine, whether it's a new machine or an old machine you updated, it's important that you get some sort of baseline check when you do the machine so that 3 months from now you can go back and check that. Either you check it or you have us come in and check it or whatever. But it's critical that you want to make sure that, you know, it maintains that quality because it will affect your part quality, some of these parameters. And then also that these are just more parameters, but it's important that these are turned on. A lot of these, if you had the option turned on by the builder, they'll have generic values in there anyway, but it's still important that you do some sort of quality check with an artifact or something like that to make sure that everything's within the tolerances of what you're expecting from your part quality. And this is something like Rick can help you with this or Mark can help you with this. Not so much my group, but Rick's group is more than capable of getting you the type of help to help you do things like that, or our service group. Another very important parameter is this 19696. This is one where you tell it whether you're working off a table coordinate system or the workpiece coordinate system. It's very important that this is set correctly because, again, this is one where if this is set incorrectly, the machine's going to do some strange things, strange moves. Okay, so I can't emphasize enough. Some of these parameters, it's very important that they're set correctly. Okay, another thing within TCP, tool center point control, you know, when you get your machine and whatever type it is, whether it's like a B axis with an A on top, a B axis with a C on top, as you can see from this, sometimes these 2 axes, the 2 rotary axes, might not necessarily intersect. I mean, of course, we're going to say mechanically it's always going to be perfect, but that's not always the case. So with TCP, there are parameters that are related to this kind of error. And you can go in and offset X, Y, and Z, whatever it might be, to get those back in line. So up to a certain degree, obviously you don't want to go in there and put 10 inches, but you can go in and offset it to allow for mechanical error between the two rotary axes. Okay? And the three parameters that do that are 19703, 704, and 705. So these are very important to know where these are also, because invariably, again, your builder will put certain values in here, but again, these are ones when you have the machine set up that you go in and check it and fine-tune these to make sure that the rotation, the intersection point between the two rotary connections is dead on, because otherwise that's going to affect your part quality. Okay, then go on from there. Now this is just another representation of some other parameters that we typically use. And this would be one like you'd use if you're going to use a right angle head. You can actually use tool center point for that too. You just got to make sure that you have a value in 19711, which is typically your pivot point. And then also, while we're here, just to let you know that a lot of machine tool builders, they actually, with the tool center point or Workpiece Setting Error Compensation, they will have written special screens specifically for some of those features, where instead of having to use only the way we do it, they might have a special screen that you can allow for that. And I just want to make sure that you're aware of that. A lot of builders will have their own special screen for that. So, and then to go on from there, our next thing we're going to talk about is high-speed machining, because this all ties in with, the tool center point. And just to talk about the FANUC system, it's very important to understand that, when you get a machine with a FANUC control, it's just not the control that separates us from everybody else. It's the entire system, because HRV is a digital current control method that works in conjunction with the CNC, the amplifiers, the encoders, and servos as a system, not just by themselves, but as a system. So it's very important that not only is it we can make the part fast, we can make it smooth, and we can make it accurate. And we can do all that together, because everything is tied in together. And this only shows HRV3. At this point, we do also have HRV4, and it cuts everything in half. So it makes it that much faster and more responsive. Because if you got something that's looking 10,000 blocks ahead, but if you don't have the motors to keep up with that, it doesn't matter. It doesn't matter. You got to have a whole system that works together to make a fast, smooth, accurate part. Okay. And then some of the options that you need, and again, these are ones I'm just touching on. There's much more that needs to go with these. But AiCC2, high-speed processing, and extended block look-ahead are some of the ones that you need. And then again, to turn those on in the program, it's a G5.1 Q1 actually turns it on. Typically, you'll have an R word in that line also to select the different levels. Okay. And then, talking about look ahead, and again, FANUC loves to use the driver analogy. And what look ahead is equivalent to having car headlights turning on, so the driver can see ahead what's coming up, so he can allow for it. That's what look ahead will do. And with FANUC, you can get up to 1,000 block look ahead. And then, I do have a note of caution here that's got to do with AI control. With it, when you turn it on, it will stay in the mode, whatever R value that you have at that point. So you got to make sure that you go back, if you want to go back to fast mode, that you go back to a R1. I just want to make sure I mention that. Okay, with standard Acc and Dec, you know, that's, again, using the car analogy, that's like stomping on the gas and then slamming on the brakes. That's how the standard Acc and Dec, the exponential Acc and Dec, and standard CNCs work. And you know, if you got a new machine, it works great. We're here. We're at. And again, if you got a new machine, you know, it will let you go much faster. But when you have older machines, when you do this, when you try to accelerate very quickly, it won't let you do that. Okay, so you'll need linear Acc and Dec after interpolation. And what this does, it helps you gradually accelerate the axes. And what this does, it will help it start up gradually. The actual machine position might actually be not up to the actual speed that you want, but it'll be okay. It'll be okay. And then with feed forward, what that does, it looks ahead with feed forward. And with this, you know, we go in and set up parameters to get to where your commanded speed and your actual speed are the same. And that's very important. Okay, so what we do, we go in and tune all these different parameters, and usually what it takes is a half a day per axis for tuning. And again, Rick Schultz can help with that, also Mark Lohmeyer, and also our service group. And then also we do have, where we have more parameters, we have bell-shaped Acc and Dec after interpolation. And what this does, it provides smooth application of acceleration in the same way that linear Acc and Dec provides. And it includes all the advantages. But again, what this does, it helps once you accelerate and it gets up to speed. When it gets up to speed, you'll probably maybe go past too much and it'll have to slow down. With this, it sort of, and that will affect your part quality. So it's important that you have this because it'll make the transition be much smoother. And then you also need the same thing in the corners. And again, using the race car analogy, you know, when a race car's driver is driving, you know, he sees the corner coming. So he needs that he's got to slow down. So that's what, essentially that's what this is doing. It's seeing the corner up ahead based on the look ahead. So it knows to slow down, go through the corner at the right speed, and it'll follow the actual program speed. And then you want the same thing, you know, when it comes out of the corner. And you would think that setting up these parameters where it slows it down in the corners would actually slow down your actual program speed, but actually it doesn't. Because what you end up doing, you can end up speeding up your actual feed rate because you know that the control is going to allow for the corners or any radiuses or whatever you might do. So you can program the straight at whatever speed, and the control will allow for the corners. And again, this is just talking about jerk control where we're making it smoother. Okay? And again, just to talk about building the optimal toolpath again. This is a programming, this is just showing a 3-axis machining example. And you know, we have G5.1Q1, where it turns on AiCC. The G43 calls up your tool length. G41 is tool nose radius compensation, and then you turn it off at the end. Then for 5-axis, it's basically the same. You turn on the AiCC, G43.4H1, then a P1 will turn on tool center point control. And if you need three-dimensional cutter compensation, and then you turn them off at the end. And then we get into quality adjustments. This is where you can set up levels of different quality or their speed, however you want to describe it, whether it's precise or less precise, fast or slow. And again, I want to show another video here. We go into videos, and with this one, we want to go into this. And with this, it'll show, okay, it's selecting where it's going feed fast and precision low. And you can tell the type of finish that it was getting there. Now we're going to go to a more precise level, feed slow, precision high. And again, you can either do this from this screen, you can select it, or now see here where it's shown where the finish is so much better. You can select it from that screen or with an R word within our program. Okay? So now we'll go back into our PowerPoint presentation. So that's how that works. And that's a very good feature. Again, like I said, another great feature that we have, because as we discussed before with 5-axis machining, with 5-axis machining, you want to make sure that, with your fixturing, as I said, you need to be able to get all the way around the part. With this three-dimensional interference zone check, with it, you got the capability of turning this on, and what it does, it will actually, you can import a basic IGES model where you can create interference zones. And with that, then you can display the interference object list, and you can actually go in and do an interference check execution right on the control. So again, I want to emphasize that this is very important when you do 5-axis machining, because like I said before, it's not like throwing a part up in a vise. You're going to have special fixturing. You need to be able to get all the way around the part. So it's important that you have some means of being able to go in and actually machine all the way around the part. All right. Now another one that we have is 3D cutter compensation. Now with it, what it gives you the capability of doing is using different diameter tools to use the same program. And with it, you have several different types of tools that you can use. You can use a ball nose end mill, a radius end mill where it's more square, it's only got radiuses on the corners, and then a square end mill. And again, I'm going to go try the video again. And if you're not seeing this very well, I apologize. But again, it's showing it's cutting 5-axis all the way around it. And it's going to change tools. So as you go around it, using the three-dimensional tool nose radius compensation. Again, this is another great feature within 5-axis. Again, you end up with the same part. Now we'll go back to our PowerPoint. Now we're going to talk about tool posture control for tool center point. And again, to program this, you use a G43.4 and then with a P word that turns this on. And with this, the tool moves in a plane defined by the tool vectors at the beginning and the end of the commanded motion. And with that, then what that gives you the capability of doing is cutting around using the whole side of the tool. It gives you that capability. And what it does, without it, you're going to get scalloping. And once you turn it on, it will make it smooth. And again, I'm going to show a couple videos. And again, if we are having trouble with the tool posture control or any of these videos, I apologize for that. But see, it shows this with it off. As you can see, let me play that again. You know, you can see at the top, you know, how the tool is making some different moves. And then if you go in and play it with it when it's turned on, okay, now when it turns on, it's much smoother, much smoother, okay. We go back into our tool, into our PowerPoint presentation. And again, then we go on from there. And what's good about this, you get tool side and tool center point work smoothly together and produce a quality machine surface. And this is good for aerospace parts, you know, machine blades, ribs of aircraft. And then you can get programs for conventional tool posture control are available. And again, then with high-speed smooth TCP, you can see the first example here of a cutting. And see, you can see the faceting on the side. And what we can do with smoothing smooth machine surface, you get a much smoother finish, much smoother finish. So that's some of the different features within high-speed smooth TCP, tool posture control. And again, I just want to reiterate, with the FANUC system, that within it, it's just not the control itself. You know, the thing that we got to think about mainly is that we're providing a total system where it's the control, the drive, the servos, the amplifiers, and all that total system where, you know, it's just not one thing that's making it all good, it's the total system. Okay, and not only the hardware that we provide, the software we provide, but also the support after the fact. You know, like my team, the aftermarket support team, Rick's team, the vertical marketing group, they all support you when you want to do 5-axis type work. Also, our service organization, they will go in and help you out there also. So, you know, we're totally dedicated to customer satisfaction. And again, like I said, it's the system where we got everything together. We also have a, you know, all of the employees at FANUC, we all try to work together there also. From our sales team to our service team to the vertical marketing to the aftermarket support. So parts, you know, training, all of our engineering group, you know, we all try to work together just like the system that we provide on your machine. And then, you know, we have innovative automation solutions for a variety of different things. You know, we have 3 million CNCs out there, over 14 million servo motors, 250,000 robots, so, and, you know, one undeniable global leader, you know, FANUC America. You know, so it's a total system. It's just not, you know, one person or one control or whatever. You know, it's a total system. So at this point, I'm going to pass it back to Mark, you know, where if we have any questions or anything like that, we can go on from there.
Okay, thank you, Jody. That was very interesting, a really informative presentation, especially like the videos. Yeah, we do have questions from our audience, so we're going to get started with those. In the meantime, everyone, please feel free to submit your own questions by typing them into the question pane on your control panel at the right of your screen. And we're going to try to get to those answers as we can. We'll answer all the questions. We may not be able to get all of them during the live portion of this webinar, but this webinar is being recorded and it's going to be available online. If you can't stay for the whole session, you can catch up later and we will catch up with all the questions either now or after the webinar is concluded. So let me jump in with our first question here. This goes back way, I think, to the beginning. Why do I need to turn the part program functions off at the beginning of the part program?
Well, it's just, Mark, it's a safety thing. You know, it's an old program thing where if you would leave, especially a lot of them, like drill cycles, tool center point control, a lot of the features that you would turn on, you want to make sure that they're turned off. Because if, say you turned on tool center point and for whatever reason didn't turn it off, and then you would go in and pull it, went somewhere where it was going to do an A or a B command, it's going to move all the axes at once. So you want to make sure within your safety block that you go in and turn off all those things that you've turned on. And, you know, it's just, you know, most programmers will call that just your safety lines, you know, at the beginning of the program. That's standard programming 101. You put that safety line at the beginning to make sure you turned all that stuff off. You know, 30 years ago when I went to programming school, put the safety line in. You know, you got to do that. You got to do that. Whether you're doing 2-axis, 3-axis, 4-axis, or 5-axis programming, you need to do that.
Okay. Okay. Going back to the tool center point control. How do I turn on tool center point control is one of the questions from our audience.
Okay, you turn on tool center point control with a G43.4, with an H word, and then at least a P word, because that also turns on the tool posture control. And there are different levels of tool center point control that obviously today we didn't get into that depth of it because, you know, we would need much more than the time we have allotted today. And plus, you know, at some point after that, if you need more, you know, in depth of what you need to use to turn that on, Mark, you know, myself, or, you know, you can contact us for more depth in an answer to that question.
Okay. Another one of our listeners wants to know, how do I activate tool posture control, and what does the program line look like?
Again, that's sort of the same thing that I just went over, but it's a G43.4 with an H word, and then the P word actually turns on the posture control. So, you know, the same thing. Okay. And then you control it with vectors of the tool. Okay.
All right. This question, what does the R word do in the G5.1 Q1 R1 line?
What that does, Mark, is that sets up the machine condition function. And what that does, it tells it essentially, you know, we either call it, you know, less precise or more precise. R1 is faster, R10 is slower. So, you know, you can either make it, you know, like if you're roughing something out where finish, accuracy, smoothness is not important, you'd use an R1 or an R2, something, a lower number. When you're doing finishing, you want to use an R8, 9, or 10 based on your parameter setup. And again, that's, you know, when we went through that before where you go in and set up your parameters to make sure all this stuff is set up correctly. That's why it's critical for, you know, some of our end users might need support from our service group to actually go in and set up those parameters for those values, Mark. But that's what it's for. R1 is fast, R10 is slower and more precise.
All right. Another listener wants to know, why would I use Workpiece Setting Error Compensation?
Well, again, with Workpiece Setting Error Compensation, what's great about it is, you know, you tell it where the part is, and plus it's truly dynamic. it does move with all the different 5-axis moves. That's what's key about it. Because, as Rick has really beat into my head, and then I tried to reiterate it in our presentation today. One of the first things you need to do in the program, you got to identify the part location. You got to tell it where it is. So that's why it's critical to use the Workpiece Setting Error Compensation along with the tilted working plane. You got to tell the machine where the part is. It's important that you do that.
Okay. Another one of our attendees would like to know, how often should I check the TCP parameters?
Well, we recommend, and that's a good question. We would recommend in the beginning, initially set it up, and then 3 months later, check it again, to make sure, your machine wears in, your ball screws wear in and everything like that. The machine settles, because, even the level of the machine's going to affect it somewhat based on where you have the machine. So we would recommend up front to do it every 3 months, and then after 6 months, and then after that, if it doesn't move very much, then you can get, most people will get to where they'll do something like this maybe once a year. But in the beginning, you want to do it more frequently to make sure that you do have the machine stabilized. So at least every 3 months initially.
Okay, all right. Another question here from our audience, will these options allow my machine to make parts faster?
Yes. Yes, it will. It will allow your machine to make parts faster. But again, just to reiterate again what we had talked about before, Mark, is that it's important that you get the parameter content correct in order for it to make it faster, because you have to do machine optimization, because with that you go in and set up the most optimized setting for all those parameters that have to do not only with PCP but also your high-speed parameters. Those have to be set up correctly, because like I said, the builder will have generic values in there, and they'll be pretty close, but you want to fine-tune those. And like I said, it'll take a half a day per axis for us typically to go in and do that, but it's important that you do that. It's because then you can make the part faster, and it'll be accurate, and it'll be smooth. So it's important that that's how you make it faster.
Okay. I think we have time for maybe another question or two. One question here. Where and how do I get a copy or view the recording of this webinar? And
yeah. Well, I guess it's going to be on a couple places, right? At some point it's going to end up on YouTube, and then also it will be on your website, right?
Correct.
Modern Machine Shop. So
yep.
It's going to be at least 2 different places where they can view it. And then at some point it should be on our website too, I believe.
Okay, all right. Okay, we have other questions that I think we're going to have to take and answer when we're offline here. Unless you have some other remarks you want to make, Jody, to sum up?
Well, like I said, just to sum up, as you said, if you have more in-depth questions, if people can, send them to you and then they end up with us, between all of us, that work on 5-axis stuff. Like I said, I'm usually my group is only the support, once the machine gets on the floor. But, between myself and my group and Rick and all the people that help him, we will get through all the questions and answer them.
Okay, great.
That's my summation.
Okay, great, Jody. Hey, thanks again for presenting your slides and answering our questions. I've moderated several of your webinars, and it's always been a pleasure. You do a great job. I also want to thank Rick Schultz and Mark Lohmeyer for helping us out. And for all those attending this afternoon's session, you can contact FANUC America if you'd like more information. Again, that information's on the screen. So we really appreciate the time you've taken with us this afternoon and hope you found it worthwhile. So thank you for taking part in this live portion of the webinar. And my thanks also to those who arranged this session and helped it go smoothly. So this concludes our webinar. Have a great day, everybody. This is Mark Albert at Modern Machine Shop Magazine signing off.